Our tools for manipulation, measurement, and abstract description of landscapes are a direct result of the resources available in and of the Earth. In this sense, the age of machine learning afforded by planetary scale computation is the Earth revealing itself to us. It is in this spirit of machine relations that the future of land description and ownership will be reconstructed. The evolution of the concept of delineation and ownership of land has roots reaching as far as documentation of human activity records. The concept and governance of land ownership will become pivotal in the coming decades as our changing climate will alter patterns of human and animal settlement, increasing density in inland, urban, and rural communities alike. Currently, there are two basic models of ownership of land. One granting humans the right to own land outright through legal deed, common in the United States. The others are varying forms of leasing or tenancy to citizens by institutional or governmental organizations. Nearly two-thirds of the land in the United States is privately owned, and of that, vast amounts are owned by only a handful of families, concentrating the power to shift and repair environmental conditions in the hands of a select few worldwide. The ever-increasing role of generational wealth and the increasing complexity and intersubjectivity of the global economy are exacerbating the inequalities rooted in land ownership, with little incentive to change course until the warming climate forces its hand. Various models of land ownership have evolved over time from a culture of collected subsistence and ecological stewardship to an abstract concept maximizing extraction and productive value from the land. The traces of such production are clearly legible and nearly inescapable on the landscape. These concepts and their enactment have provided subsistence and shelter for booming populations and made possible the technology that many of us depend on for our health, education, livelihood, and recreation. These concepts also contribute to cultures of human exploitation and habitat destruction that the marriage of land to value have created. Our attitudes toward the landscape and its value are simultaneously revealed and constructed by the various languages we use to describe it. From the narrative cartographies of ancient civilizations to the abstraction of the land through the language of treaties and deeds of ownership, to the planetary scale collection of data that offers up a landscape of continuous information modeling. Each description acts independently and serves to isolate a particular point of view. Despite shifting states of social, political, and environmental needs, current models for conceptualizing ownership of land have stagnated. Reflections of obsolete models of governance based on imperialist representations and outdated modes of computation and documentation. Perhaps current trends in cryptocurrency and virtual land NFT sales made possible by blockchain technology are the harbingers of the future of value and its governance. Contemporary machine learning models like generative pre-trained transformers and contrastive language image pre-trainers are already at work changing the syntax and semiotics of everyday text and language. Autocorrect, autocomplete, chatbots, and the more sophisticated GPT models have already been absorbed into social norms of communication without our noticing. Cheer moms are creating deep fakes from their phones. These alternative intelligence tools are a direct result of the vast amounts of data that our rare earth minerals have made possible. And it is these alternative machine languages that will shape the future of our landscapes. Able to predict the next word, given all of the previous words within a select body of text, GPT is chameleon-like. It adapts its output to the style and content of a body of finely tuned conditioning text, not unlike image-based models that map a particular graphic style image onto a content-setting image. The output images are statistical extractions based on convolutional networks that resemble the organization and patterns produced between neurons, similar to those in the human visual cortex. However, this statistical pattern matching is capable of something difficult for the human neural network. It is capable of intersubjectivity, interpretation and prediction that humans are not. The modern tradition of isolation of subject from object is being dissolved. The next generation of designers are going to find relevance in the editing and curating of data and its output as a creative act, disrupting the notion of the individual author. The notion of the genius, of loci, or of human intelligence is destabilized. Look where that model has gotten us anyway. This is what a model of land ownership based on an age of machine learning and prediction might look like. Big data, incomprehensible to humans, is the basis of a practice of landscape modeling that is resilient and intersubjective, reterritorializing the planet towards ends that are flexible, transparent, responsive, and nimble as opposed to static, privatized, reflexive, and Cartesian, redefining a common rights of use in an age of artificial surfaces, flood zones, and refugee camps, detecting and predicting shifts in land that are not dictated by property lines of ownership, but that move in relation to shifting climates, populations, and needs informed by spatial and multitemporal source data.